Welcome to the Deep Dive, your shortcut to critical knowledge.
Hmm.
Today, we're opening up a file that's honestly pretty stunning. It's based on real tech hiring experiences.
Yeah, the source material title kind of says it all. I interviewed 50-plus engineers. Here's why most can't code. It's definitely provocative.
It really is. And our mission today isn't just about the shock value, it's about giving you a strategic edge.
Mm.
We want to figure out this huge gap, right, between knowing about tech and actually using it.
Exactly. Knowing what React is versus, being able to build even a simple app with it.
And this comes from talking to a lot of people, fresh grads, junior devs, even some mid-level folks, looking for all sorts of roles too, front-end, back-end, full stack.
So if you've ever wondered, why do smart people with degrees struggle with basic coding tasks? Well, this deep dive should shed some light.
It's fascinating because, as the source points out, these candidates could talk the talk. They knew the frameworks, the tools.
Oh, absolutely. They could discuss, microservices, the virtual DOM in React, intricate stuff. They weren't lacking intelligence, not at all.
But then came the coding part, and
And that's where things fell apart.
mm,
The really shocking statistic from the source was this: 70%.
yeah,
70% of rejections were because candidates couldn't handle problems using the absolute basics,
T6 Lite.
like loops, arrays, working with strings, basic conditional logic, if statements.
Wow,
Yeah.
70%. That's the key takeaway right there. It wasn't about complex algorithms or fancy data structures.
Nope. It was the foundational stuff. Can you manipulate a list of items? Can you check a condition? That level.
Which makes you ask why. If they're smart enough for the theory, why are they freezing up on, say, reversing a string?
It points to a real issue in how people are learning,
Oh.
doesn't it?
The source identified a few core reasons. What was the first one again?
The first big one was over-reliance on theory, the definition trap you called it earlier. Right. They know what polymorphism is. They can define a REST API, but ask them to write a simple function to, filter an array.
Freeze.
It's like they memorize the dictionary but can't actually speak the language,
Right.
trained to recite, not to construct.
Exactly. And you see this pressure, maybe, to load up resumes with buzzwords, frameworks over fundamentals.
So they know the complex terms but skip the grammar. Okay, that's trap one. What about when they do try to practice? Does that lead to the second issue? Tutorial hell.
Oh, absolutely. That came up again and again. Months spent following tutorials, maybe boot camps. Which, look, they're great for getting something set up.
But not for understanding why it works.
Precisely. You become great at following instructions, copying code, maybe using ChatGPT snippets.
Yeah.
But then, faced with a blank file, needing to build something slightly different from scratch, they're lost.
It's like knowing a recipe by heart versus understanding how heat and ingredients interact. You can make that one dish, but you can't improvise. And that lack of confidence, that lack of deep understanding, feeds right into the third point. Fear of problem solving.
Ah, yeah. The source mentioned they see coding challenges like a scary math problem.
Instead of what it actually is, just breaking a problem down. Step-by-step instructions for the computer. It's logic, mostly.
Not necessarily high-level math, just logical steps.
Right, which, brings us full circle to the biggest reason for failure, the fourth one, just no practice with basics.
So back to the loops, arrays, strings.
Yep. The vast majority stumbled because they just hadn't spent enough time really mastering how to work with basic data.
Mm-hmm.
If you can't confidently loop through an array and do something based on a condition, well, you can't really build much.
These are more than just abstract reasons, though. The source had some real concrete, kind of painful examples. Let's talk about candidate A.
Right. Candidate A, a fresh graduate, seemed really confident, said they knew Python, Java,
Okay.
and the task was super standard. Write a function to check if a word is a palindrome, reads the same forwards and backwards.
A classic beginner problem. How'd they do?
Well, they struggled for about 20 minutes, trying to remember library functions, maybe something they saw online.
Oh, wow.
Couldn't just implement the core logic,
Yeah.
compare the first letter to the last, second to second last, using a simple loop or indices. Eventually, they just gave up.
So it wasn't lack of intelligence. It was...
Lack of practice. Real hands-on coding practice. They knew about coding, but couldn't actually code that simple task.
Okay, that's stark. And then there was candidate B. This one's maybe even more telling, a mid-level developer, supposedly with 3 years of React experience.
Yeah, this one hits home for anyone deep into frameworks. Candidate B was asked to build a simple counter app. Click a button, number goes up.
Super simple. But there was a catch, right?
The interviewer specifically said, build it without using external libraries or common React templates. just plain JavaScript logic.
Forcing them back to fundamentals.
Yeah.
Taking away the scaffolding.
Exactly. And what happened? They couldn't do it. They likely relied so heavily on things like Create React App and built-in hooks like UseState.
That when they had to manage state and update the display using just basic browser JavaScript.
They were completely lost. It shows a dangerous dependency on the tools, without understanding the core principles underneath. Again, not dumb, just unprepared in the fundamentals.
But it wasn't all negative. There was candidate C who offered a contrast.
Yes, candidate C was also a fresher, but they apparently nailed the interview. And the reason...
They had built stuff on their own.
Exactly, small things, but complete projects, like a basic weather app, a to-do list, maybe a simple shopping cart. Nothing revolutionary.
But those projects showed something crucial, didn't they?
They showed confidence and competence. They proved they could start with a blank screen, apply the basics, figure out problems, debug their own code. They weren't just following tutorials, they were actually creating.
It's the difference between reading about swimming and actually getting in the pool.
Perfect analogy. That active application makes all the difference.
Okay, so let's shift from diagnosis to prescription. Based on what worked for candidate C and what tripped up the others, what are the actionable steps? What's lesson number 1?
Number 1, absolutely non-negotiable. Master the basics. Seriously. Arrays, strings, loops, conditionals, functions. You need fluency here. It's the bedrock.
Everything else rests on that foundation.
Yeah.
Got it.
Second, build projects consistently. Even tiny ones count. A calculator, a simple blog backend, tic-tac-toe. Get away from just copying tutorials. Start from scratch. Build something.
Because if you haven't built it yourself, you don't truly understand it. Makes sense. Third point.
Third, practice problem solving daily. Use those platforms, LeetCode, HackerRank, whatever. But here's the key. Don't just look for the answer. Understand the process. How do you break the problem down? How do you approach it systematically? Focus on the how, not just the what.
Conquer that scary math problem fear by making it routine. Okay. Number 4.
Fourth, and really important for interviews, learn to debug systematically. Interviews often test how you react when things don't work.
Right. They want to see your thought process when you hit a wall.
Exactly. Can you trace the error? Can you isolate the problem? That methodical troubleshooting is a hugely valuable skill.
Okay. And the final one, number 5.
Fifth, get comfortable coding without Google or Stack Overflow or AI assistants, at least sometimes. Train your brain to rely on its own logic first. In an interview, you won't always have those crutches. You need to be able to think and code based on your own understanding.
Build that internal knowledge base. Okay, those 5 points seem critical. Stepping back, what's the bigger picture here? What's the fundamental shift needed?
The core idea is simple, really. Coding isn't just knowledge you acquire like history dates. It's a skill, like playing guitar or cooking or speaking a language.
Meaning, it only improves with practice.
Deliberate, consistent, hands-on practice. Reading about scales won't make you a guitarist. You have to actually play. Reading recipes doesn't make you a chef. You have to cook.
So companies don't really care if you can recite framework definitions.
Not really. They care if you could take a real problem, maybe a messy one, break it down logically, and then write clean, working code to solve it. That's the job.
So the goal should be to shift from just being a framework operator to being a genuine problem solver.
That's it exactly. A foundational engineer who understands the principles, not just someone who knows how to use the latest tools commands.
Looking back at those 50-plus interviews, the takeaway isn't that these engineers weren't smart.
No, definitely not. They were smart. They just weren't prepared in the right way. They focused on memorizing facts instead of building skills, on consumption over creation.
So here's maybe the final thought for you, the listener, to chew on.
Yeah, think about this. You have an hour. You could spend it learning the definition of some new feature in a framework, or you could spend that hour building a tiny project from scratch, using just basic loops and arrays.
Which hour actually builds that core, lasting engineering skill? Which one makes you better at demonstrating you can code, not just describing it?
Focus on demonstration. That seems to be the key.
That really sums it up. Thank you for diving deep with us today.